Laura, and I'll be taking you through probability notation and probability laws. Yeah, love this topic and I just hope you get it. So please guys, don't forget to like, subscribe and comment if you are enjoying any of my videos. Your comments are really appreciated. So probability notation and probability laws. Probability notation and probability laws. Probability notation and probability laws. We are saying on this topic, any statistical experiment or a trial, any trial or statistical experiment that we do, it has got a number of possible outcomes, right? And a set of all possible outcomes is referred to as a possibility space. As a possibility space is any a set of all possible outcomes that we say these are the possible outcomes that we get. It is called a possibility space. Yes. Okay. So if an event A is taken from an event A of the experiment is defined to be a subset of S. What do we mean by event A? An event A is a subset of S because we are taking a part of the S, they set all the possibility outcomes. That's what we refer to as. That's what we refer to as a. Let me just give an example. If we are using a die, we all know dice. When a die is thrown, the outcomes are numbers from 6 years. We know a die ranges from 1 to 6 on different sides, right? So a die is thrown, the outcomes are the numbers from 1 to 6. So the possibility space is for a die would be S 1, 2, 3, 4, 5, 6. Right? So this will be the possibility space, right? And then we can define our event A, the event that we have taken from. So here is an example that the score is less than 3. So for example, like we toss our die, right? And we toss our die and what is the probability that we obtain less than 3? So we say for event A, like it's not like we can stick to A, it's just an example, but we are saying it's an event that you have taken. For an event A, it's because we need below 3. The probability that you get the value which is below 3. So here it will be like A. The possibility that you get below 3 will be 1, 2. This part 1. So this is what we are referring as the subset of S, right? This is the subset. This is the main set, and this is the subset. The subset which is A, 1 and 2. So for an example, we might be given another example that if we throw 2 dice, there are 36 possible outcomes shown by dots in the possibility space. Let me just show you like this. Here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the first die. possibility outcomes for when two dice are thrown is the possibility outcome will contain 36 outcomes, right? 36 possible outcomes. Second die. So this is here. So these are 36 possible outcomes that we get, right? So, if we define our A, the event that the sum of two scores is 6. What do we mean by sum of two scores is 6? That we take any side on the first die and any side on the second die, but if we add them, if we do the sum of these two dice, we obtain a 6. That's our event A. So we are saying event A. What do we want for event A? We need a sum of 6. So what is a sum of 6? Like we add them, the two, this side and this side, and we get 6. So which part do we get 6 in? We get a total of 6 on each part of of our possibility outcomes. I will start with here. If we take 5 and 1, this would give us 6. 5 and 1. If we take 5, the side with 5, and we take the side with 1, it will give us 6. If we take the side with 4 and 2, here, it will give us 6. If we take 3 and 3, this will also give us 6. 2 and 4, another 6, 1 and 5, another 6. So it's like this, and we are event A. This is S, this is A. Okay, guys, do you get it? This is our A in this. So what's happening on event A? So according to what we had said then, we are saying we have our entity. This can be called entity S. Our possible outcomes, all possible outcomes S, or it can be written as this sign. You can use this sign, just S, right? And we have our event A within the set. We have our event A. So this is our event A. Then the number of outcomes in the possibility space is the number of outcomes in the possibility space, number of outcomes in the possibility space is denoted as n number of outcomes in S. We denote it like this, ns. Let me just show my camera. This is the ns, right? Okay, let me just tilt it back. And the number of outcomes in event A. Now we know the number of outcomes in event A. Number of outcomes in event A, and this is the number of outcomes in event A. Well, this is the number of outcomes in our possibility space. Okay, so now for us to obtain the probability of the number of outcomes we obtain in A, we are going to say probability A, probability of A, that we get probability A is equal to NA over the total S, the number of outcomes in S, and the number of outcomes in the number of outcomes in A. Okay, so that's how we calculate our probability in the first scenario. Okay, so as I had said before, a probability A, if we have to obtain a probability A as 0, it means it's impossible. But if we obtain, let me write it here, probability of A, if it's 0, it means it's impossible. If we say probability of A and we get 1, it means it's very possible. It's 100% certain. Okay. Then moving on to complementary event A. Complementary event A. So when we talk about complementary, we are just talking about things that are not found in A. Complementary is something which is not found in A, but if we say A and that complementary A, we have to obtain 1. That's how it works, right? So we are saying complementary, this is A. Complementary, we are saying it's written as A. Complementary of A, right? So for us to obtain the number of outcomes in complementary A, the number of outcomes in complementary, you are going to say the number of outcomes in the possibility space minus the number of outcomes in A. So this is our A, right? This is the whole of A. But for us to, and this is the whole of our A, number of items in the possibility space. So for us to obtain a complement will be here. That which is not in A. So this is our A complement. Hence, this means that number of outcomes or possibility outcomes in S is equal to number of outcomes in A plus the number of outcomes in the complementary of A. Here. So it will be written like this. Okay, guys? So for us to obtain the probability, now the probability in the complementary of A, we are going to say probability for complementary A would be NS minus NA. NA, just NA. Over the total NS, right? So this will give us the complementary A. Okay. So note that sometimes A complementary can be written as A. But most of the times just use this. Okay. So that's it for Venn diagrams. But today we'll be focusing on. So we're going to talk about intersection with have like in A intersection, we have a common point for both the elements that will be intersecting, and this part is shown by the overlapping part. This part represents the A intersection B for the two sets. But on A union B, this represents A union B. Here we are saying on A intersection, we are saying A is both. This represents both A and B. But on A union B, this represents A oro B oro both. Then A oro B oro both. And on this part, we refer to this diagram. So this is my A and this is my B. So for this part, for A union B, we should present this whole part, this whole region. That's our A union B. So for A union B, we are combining the elements that are in A and combining the elements that are in B. That is for A union B. But now, on A union B, we have to take note that there are elements that are at the intersection. These elements, let me give you an example. We can have A being 1, 2, 3, 4, 5. And here our B is 2, 3, 4, 6, 7, 8. So when we are like asked the sum of A union, for A union we are taking the sum that is